Hello, everyone. I'm Steph Rogers, and I am so excited that you're joining us for season 2 of LunchBytes. Welcome, everybody. This is a show that we put on every other week. We bring in experts from around the UK, within Microsoft and outside of Microsoft, to talk about the hottest topics that you've asked us to cover for Azure. Really excited to share this with you all, and we've got some excellent speaker content coming up. But before we get started, just to share a few bits to cover, I'm going to pass over to my colleague, Asta.
Hi, everyone. So just a few little housekeeping rules for today. If you could be aware of others, be respectful, welcoming, and kind and considerate to others, especially in the comment area as well. And feel free to drop in questions throughout the session today. Another point as well is that today the whole session is capable for accessibility. So we have closed captions available on demand as well. So a little introduction. So to our team. Hi, everyone. My name's Asta. So I'm a cloud solution architect intern at Microsoft, and I'm in the app innovation team, focusing mainly on Power Platform. I'll pass on to my colleague, Steph.
Hey, everyone. I'm Steph Rogers from earlier, and I focus on our developer engagement and audience community work over here in Azure. And we also have put on for you a Cloud Skills Challenge for this event. So that is something that you can join. There's swag to be attached and more that you can participate in, and that you can access at aka.ms/lunchbytes/cloud skills challenge. Just over here.
Great. And hi, everyone. I'm Ty Brennan. I'm a cloud solution architect in the UK in the same team as Asta, so focusing on all things developer focused and some of our platform as a service services. So it's great to be here. And now in today's session, we've got a really exciting, brilliant session. So John, I've just brought you up on screen. We're going to be talking around chaos engineering and load testing. But before we get into that side of things, do you want to give a quick introduction to yourself?
Yes, hi there, everybody. I'm John Metzger. I'm a cloud solution architect. I work in the same team as Tig. I'm interested in chaos engineering, of course, but PaaS services, app services, basically how to build apps and workloads on Azure in a successful way.
Yeah, and in the past we've had you on talking around load testing before it went generally available, and now it's a good sign it's gone generally available again, which is great. So we've got you back to talk about that in combination with chaos engineering. So it's going to be a really good session. I'm very excited to listen to it. We've got about 45 minutes worth of time in this session. And I know that we're going to do a couple of demos later on as well. So if, like what Asta said, if there are any questions that come up that you've got whilst watching, feel free to put them live into the chat, because we'll have a Q&A time at the end that we can get to, and we can raise your questions there. So without further ado, John, I'm going to hand over to you to talk us through the session.
Okay, thanks, Tig. So what we're going to do is have a few slides first to talk about resilience, the kind of impacts of resilience, and then kind of why Chaos Studio sort of came to be. So we all, of course, know that service outages impact availability. We know that, and we know that the bottom line for a lot of organizations is it costs money when you have outages. So these things have kind of been known for a long time. And at the same time, quite often the people who develop the system often then get involved in outages, and therefore productivity in your developer teams also goes down, because they're trying to fix things that perhaps shouldn't have gone wrong in the first place. So kind of what we need is some sort of quality practices that allow developers to find these problems earlier and improve them, so that first of all there's far fewer business impacts, but also, I'm an ex-developer. From a developer's perspective, we're spending more of our time developing stuff than on trying to triage and help with production issues. So next slide, please, Ty. Yeah. So real-world consequences, are there. There's a few examples here. These are all public known outages, but these can be really expensive. They can cause disruption for businesses, and in some cases, can completely destroy a business. And so that can be the size of the outage and the opportunity cost to a business can be completely out of proportion. So there might be a service that is $100 a month to run, but if that is in your e-commerce system and it stops, that one service stops you taking orders, the actual business consequences are really large. So this is the thing that needs to be appreciated is that even though some of these services may not be that complicated or that big, if they're in a chain of services that stop a business, for example, taking orders, or an airline booking flights or scheduling their pilots, then the consequences are multi-million-dollar in the space of minutes and hours. Okay, so next slide. So chaos engineering is a sort of a general term. I think the original concept came out of somewhere in the past, possibly Netflix has certainly been a company that's been associated with this stuff in the past, is about trying to go through a process improvement cycle where you work out kind of what your hypothesis, what things could go wrong. You then devise an experiment, run that experiment, do some analysis, and just go through this sort of hopefully virtuous circle of improving things. I think that one of the things that it's important to understand with why chaos has become so important is, whilst we all try and build systems that are themselves resilient, everybody says, oh yes, we don't have a single point of failure. It's sometimes very hard to validate that the mechanisms you've put in place really do what you think they do. And chaos engineering is about running a series of experiments that really do inject all sorts of faults into the system so that you can see what actually happens when something goes on. So next slide, please. So Chaos Studio is a Microsoft service. It's still in preview. I think it will GA sometime this year, hopefully. I'm not in the product group, so I can't, commit to a time frame. But it's an Azure service. You can find it in the portal, and like a lot of our services, it's managed. How it works behind the scenes is managed by Microsoft. But if we look on the kind of the left-hand side of the diagram, there's a portal experience. There's an API, so you can drive this thing headless, and it coordinates a series of, it allows you to build experiments that use fault libraries. And if we kind of look on the right-hand side, the customer solution, faults can be injected in a number of different ways. For those that kind of live in the virtual machine or containers world, these things can be done at either the virtual machine agent sort of level, where they're injected as an agent into a virtual machine, or they can be done at the infrastructure level too, so that we can directly at the control plane of a number of our services inject faults. And these things have been quite hard to do in a controlled and systematic way in the past. An important part of it is the little final line, safeguards. You really do want to be sure when you're executing a chaos experiment that you're doing it against the target that you intend, because there's nothing worse than running a chaos experiment thinking that it's, for example, against some dev test workload, instance of your service, and you found that you've done it against the production one. So there are quite a few safeguards in it, which mean that effectively the experiments have identities that need to be all enabled in order for the experiments to work. We perhaps can talk in the Q&A later about the value of doing chaos in actual production workloads versus test workloads. For the rest of this talk, we're doing stuff against test workloads. So next one, please, Ty. So a chaos experiment just has a bunch. So effectively, the left-hand side, the elements, and the right-hand side is the sort of the overall process that you do things in. So the right-hand side is really about this whole experiment, analyze, improve, and sort of circular improvement thing. On the left-hand side, at the simplest level, this is the kind of the sort of naming of things. So you've got workloads, targets, applications, and looking at the sort of telemetry behind the scenes. We'll come to this in much more detail when we do the demo. I think next slide, please. So, as I hinted on the previous slide, there are a number of different things can be done, and there are a number of scenarios that are useful to validate. So for example, you could have a DNS outage, an availability zone. If you know what an availability zone is, a data center within a region, one of those could go down, and if you spread your workload across availability zones, then it should be okay. But this is about validating that it really is. You can validate that if, for example, a database fails over from one region to another, we can look at not just pure working, non-working style failures, but also things where we can sort of remove a certain amount of memory or create CPU usage on a machine, so that you can see what happens when a workload gets disrupted by, for example, a noisy neighbor inside a Kubernetes cluster, and right down to things at the network level. And as I indicated before, in our fault action library, there are effectively two classes of faults. Ones that sort of work inside a virtual machine, and they can be quite granular, and we'll be later talking, going over one inside Kubernetes cluster, and the other ones that are much more what we call service direct, which are about doing something in the control plane to something like shutting down a VM, failing over a database, causing you not to be able to get at something at DNS or network level. So some of those are done at the control plane, and some of those are done inside effectively a virtual machine. So next slide. Okay, we're on to the demos. This is the interesting part.
Yeah, I think it's some of the value it really offers is it's testing that is actually realistic to what's going to happen in the real world. Sometimes you can't fabricate these kind of things without a bit of chaos engineering. So I think it's really valuable. And do you want to give us a quick for the audience, like a setup what this first demo is sort of going to be about, John?
Okay, cool. So for this first demo is going through a chaos experiment against a web API that's running in Kubernetes that's back-ended with a Cosmos database. A fairly familiar pattern to lots of people, a web API to a database. They just happen to be an AKS-hosted web API to a Cosmos database. And looking at how it is that workload can fail. And I think this first part of the demo is very much about looking at what can fail inside AKS, and then in the later demo we'll look at the Cosmos end of things, as well as a kind of a more interesting one at the AKS level later.
Okay, brilliant. All right, I will add demo up, and it is running.
So Chaos Studio is an Azure service just like any other, and kind of when you look at Chaos Studio inside the portal, there's two major parts of it: targets and experiments. And targets are your actual services, and you can see I'm highlighting here, there's a Kubernetes cluster and a Cosmos database, and these are enabled. And I've got a virtual machine scale set for those AKS types. That's the actual node pool for AKS. So if you're a Kubernetes type, that's the actual engine that the Kubernetes runs under. So the other half are experiments, and these are the experiments that you build that do things. I've got one here called AKS pod kill, and you can see here that there are a number of runs, a couple of which failed. We can talk about that later. But essentially an experiment is a kind of like a mini workflow of a series of steps where you can have branches and steps, and the actual action on these steps is the actual fault part. So this is kind of the meat of what's going on. And in this one here, it's a chaos mesh pod chaos. So this tells me that this is doing something at pod level. And in order for Chaos Studio to do this, I've installed a chaos mesh into the AKS cluster. this chaos mesh takes a piece of JSON, and in this instance, it's basically saying fail one pod with a particular selector, which says, and that fail the pod, one of the pods in the health check namespace inside the cluster, and we'll see that in a bit. So this is very much running at the pod level inside the cluster, inside an AKS cluster or Kubernetes cluster. Cool. So if we start the chaos experiment, it goes through a series of steps and then executes it. So in order to test a chaos experiment, we kind of needed a workload, and I kind of introduced the workload before, and it's a Kubernetes hosted API, and here's my Kubernetes cluster here, which I've just highlighted, and then the Cosmos database below it. So this is the kind of the system under test, the workload that we're going to be doing stuff with. So if we look at kind of AKS itself, we can have a quick look at what the workload is inside the Kubernetes cluster. And you do that by kind of clicking down the side, choosing workloads. And most of this you can see here is, for those that do Kubernetes and AKS, most of these are pretty standard, but there's a couple in here that I'm just highlighting now. This is the Chaos mesh that's installed into the cluster that Chaos Studio controls. So Chaos mesh is like an open source project, and it provides the API surface that Chaos Studio drives. And our actual workload itself is really dead simple. It's called Humongous Healthcare API. It's not my name, I'm afraid. It was something I borrowed from somewhere. And you can see there's 3 instances of that particular pod. Yeah, so 3 of 3 are running. And if we look at the services, you can see that this thing is exposed as a public IP address. I know these things should be through an ingress controller, but this is nice and simple. And it's got a health check endpoint, and you can see a bunch of JSON coming back if I do a get. If I do a post to that endpoint, I can stuff documents into the Cosmos database. So it's a really, really simple but illustrative API that's running on the cluster.
Yeah, I could see things like patients, symptoms.
Yeah, and then, the healthcare thing. I mean, for the purposes of this experiment, it's kind of it's an API that we're testing. So now we need to be able to generate some load. It's really hard to get a sense of what's going on if you've had an outage unless there's some load against it. And this could be why the origins of running against production come from. We need load. But what we've got, and I did this in the previous LunchBytes, is Azure Load Testing. And here's my load testing service. It's a service like any other. It's relatively simple to use. And I've got one here called Chaos Load Test, amongst others, and we're going to click in and have a quick look at that, just to give you an overview of what the load test is actually doing. If we sort of there's some runs down the bottom, previous runs, run history, and we'll go to that later. So when you edit a test, a load test, you upload a JMeter JMX file, which you can see here. This one's called AKS Chaos, and it's been uploaded to here. And like a lot of JMXs, you can parameterize them and drive in parameters. And in this instance, I've driven in the IP address that we were just using earlier on, and the path as well. You can also set a number of engine instances. This is for high load. For the purposes of our test, you don't need it. And load testing can also look at the metrics of the server, so you can get interesting metrics back to help you understand what's going on. So that's the load test definition. And so next, I think we're going to what are we doing next? Yeah, so we're going to start the experiment. So let's just find our experiment again. Lost track of where I am.
We're going to have a look at the experiments, right?
Yeah, we're gonna so another aspect of load tests is that each of these, these chaos experiments, is each of these has an identity, and this forms part of the authentication mechanism that stops you running a load against the wrong thing. And you can see there's a couple of failed ones here in the runs, and these are ones where I've not set the identity up correctly. So this is kind of the belt and braces thing. We've enabled our cluster to say yes, but what we do is when an experiment's created, this has a managed identity that is going to be used against that specific AKS cluster. And because this fault is an AKS chaos one, if we go into our Kubernetes service, what we've had to do is grant cluster admin to this particular thing. To, as you can see, the managed identity in here is exactly the same name as the chaos experiment. So this is the belt and braces way of saying this experiment is allowed to do things to this cluster.
Yeah, pretty crucial, I guess. You don't want other experiments. Pretty crucial in that you don't want experiments being able to affect like certain pods that you don't want it to affect.
Yeah, and that's how you get failures of the test run. So now I'm going to start the experiment. And what's difficult to do on a demonstration like this with load testing as well is coordinating the two. So we're going to be looking at the results. So what we can see here straight away in the cluster, we've injected this pod fault. And so now you can see there's only 2 out of 3 of those pods running, whereas before it was 3 out of 3. So this is a really simple one because we said to it, reduce by 1 the number of pods in that namespace. If there was other things in the same namespace, they would get reduced too. So this experiment is now running, and for the 10 minutes, I think I set as the parameter for this thing, this will run. Because I can't do this stuff in real time, I've got the results from a, here's what I prepared earlier run, and this is in a GitHub repo that I've got of a workshop that does this, that is a public-facing repo. And you can see that, once again, it's 2/3 of the pods are running. Now, if you look at this load test result, and these are the main graphs from the load testing service, you can kind of see that I've put some little helpful arrows in there, because what you can see from this is that on the top left-hand side, there's a ramping workload here where it ramps up, goes along and down again, a typical workload shape, load testing shape. But what you can see here is that this is requests per second. The throughput has suddenly jumped downwards. And so what you can see here is that the throughput did change, and there was a spike in errors coming from the service on this thing here. And eventually it sort of settled down. But then with this as well, the response time. So the request went down, the response time increases. And this is kind of what you would expect when you see suddenly only having 2/3 of the capacity. And it isn't unusual to see errors. I mean, in an ideal world, we don't want errors. And this is kind of why you run experiments, because you're thinking, okay, I'm at 2/3 capacity, but why have I had errors? Could I have done, could my code have done a retry or something? Yeah, so that's the kind of result of a fairly benign experiment, one that is definitely impacting the workload, but not by very much. But you can see that you can target specific pods, and inside the cluster, this one is stopping a pod. You could do CPU pressure, you could do memory pressure. Relatively simple use, but it shows all of the moving parts.
Yeah, I guess it's important to note as well that because you've got load testing, Azure load testing being done separately, kind of chucking a load of load whilst this chaos experiment is going on, you can tailor how much load you want, for example. So we've done here, we did a fairly simple kind of load, but you could chuck loads of traffic to simulate a scenario where you do lose 1 pod or 2 pods under a high traffic scenario. So if you're running a a website, for example, and you're going through a sales process, or it's Black Friday, for example, you want to simulate that traffic compared to like a normal Monday, you can do that in combination with load testing. I guess that's kind of the value of it, them being used together for now, right?
And right now you have to kind of manually coordinate the load test with the chaos experiment, talking with the product group. They might well be using load testing as an action step inside that kind of workflow of the experiment. And that way it would be, you don't have to manually time the two, because I've had to manually start the load test, and a few minutes into the load test, start the chaos experiment in order to make sure it lands right in the middle of the load test, so I can see the before and the after.
Brilliant. Should we jump into part 2? And I guess what's kind of the summary, or what should people expect to see different in this part, John?
Yeah, there's two parts to part 2. The first one is the API is in 2 parts. We've concentrated on fiddling around at the pod level and stopping pods in the AKS cluster. There's a Cosmos database. What happens if that fails over? So that's the first part of this demo, and that one's quite surprising. But once again, it's good to see these things. And the second one is kind of, in many ways, more interesting, is what actually happens if one of those virtual machines in the scale set of AKS goes down. And yeah, that one was quite surprising to me as well. So let's get going on that one.
Great. And anyone watching live, if you've got any questions, please put them into the chat. We'll get to a Q&A section after this demo as well. Okay, here we go, John.
Yeah, so this one's called Failover Cosmos. That's the name I've created the experiment, and this is when I sort of drill into it, is something that's, Cosmos has this idea, just like SQL, of you can have a writable region and read-only copies. So if you look at our Cosmos database here, we're normally writing to West Europe, but we've got read locations of West Europe, North Europe, which effectively means North Europe is a read-only copy. So that's kind of the normal as-is state. And normally speaking, you'd have your Kubernetes cluster in West Europe too. So looking at our experiment, this Cosmos failover experiment, it's a pretty simple experiment, and it has a step on it that's called Cosmos DB failover. So this is the fault. And this fault is being injected at the control plane level. This is one of these ones that's not at the VM level. This is right at the control plane of Cosmos. And it's basically saying fail over to that read regions, which is why it says North Europe there. So it says effectively saying fail over. You can have multiple regions with Cosmos, but this one's saying fail over from West Europe to North Europe. So it's a pretty simple experiment. We're starting the experiment now. Meanwhile, we are running our load test. I've had to edit this down. Normally speaking, you're just starting your load test, be doing this. As you can see, there's a life cycle. It's just started now. That the Cosmos failover has just started. And this one's failing over for... so when we look back at Cosmos, when we initially look at it, it's still West Europe. And eventually, as we refresh this page, we'll eventually see that it will jump over, and as you can see here now you can see the right location is North Europe. So that's done the failover to North Europe, and West Europe is still now a read-only region. So that failover's happened. So that was pretty straightforward and simple. And I think that what we really want to do is now look at the sort of the load test for that. And I'll do that by just looking in one of the historic load tests that I've run. So get back to our chaos load test. And there's a previous run down here. This is where you can see the run histories with descriptions of what each run was for, which is dead valuable. And so what we can see here is not much really. And this is really quite fascinating. Right in the center of this one, you can see this sort of kink in the middle. And what we can see here is that, just this kink here where effectively the request per seconds dip down. Now, the way you'd explain that is because the app and the database are now in different regions, it's not going to have the same throughput. But you can see that out of 1/3 of a million requests of that load test, we never saw a single error. And that was quite surprising to me. There wasn't even any on the failover point, and that
That's
might well
amazing.
be, the SDK for the so just for Cosmos. So no pool issues is the second one. So pretty benign, that particular one. Very interesting that it was so smooth. No pool issues is about doing something to the virtual machine that is running the workload. And if we look at the fault, this is basically saying shut down a specific, the virtual machines are in a virtual machine scale setting, AKS. So it's basically shut down one of the instances of that. And if we start that experiment, get the usual pre-processing running, we're not going to do all the identity bit, it's all the same as the other experiments. And we'll just have to wait to see what happens. So let's just look at this is the virtual machine scale set. So this is the underpinning node pool of the AKS cluster. And if we look at the instances of it, initially we can see that we've got a 2-instance cluster, I should have said. Two instances of the node pool. If we refresh, we can then suddenly see that one of those instances is stopping. Now, depending on what workloads are running on each of those instances, this might either be really quite benign because you've killed one that's not got much on it, or it actually could be quite devastating. And it kind of emphasizes the importance of these sorts of experiments. I was thinking when I ran this experiment, it would just kill off my my own API pod, but let's just look inside the cluster. And it's killed everything. Yeah. So it's actually taken down a lot of the pods. So what you can see here is this particular configuration of this cluster, it pretty much took it down. And it does come back again, but it just says when you're looking at how you spread your workloads across your node pools, even though we had 3, those 3 could actually end up on the same instance. So you've got to be really careful, and this is why these experiments are good. And we can look at the load test here and just see that it's just such a nightmare that even load testing decided to quit the test because it was generating so many errors. But what you do see is that the cluster eventually recovers. It's, Kubernetes is desired state. And even though the experiment's still running, it eventually comes back in a workable state because it's moved the workloads onto the one live instance and running the API. You can now see it's back live. And you see I'm still running the experiment here. So this one had a bit more of a devastating effect than I originally thought, because I thought, it will just do a bit, but it took down quite a lot of it, and it took the cluster a few minutes to come back. And I think that's really why it's really important, is that you can get caught out and think, didn't expect that. And it's also why with AKS you should really keep your control, your system nodes in a separate node pool from your applications too. So AKS is very, very powerful, but it puts a large responsibility on you to configure things correctly so that a single failure of a VM instance doesn't have a widespread problem.
Yeah, John, you absolutely destroyed that that node there with the test. That was quite funny. I mean, that'd be a very worrying sight for any testing engineer to see all that orange. But actually, whilst the load test was going on, for it to recover, that is really cool. I think, how you would be able to replicate this without Chaos Studio is interesting. It really sort of helps to get a better understanding of your apps.
And it's the repeatability too, I think. Yeah. So these experiments allow repeatability, which which is harder if you're trying to just go and fiddle with and kill things yourself, which sometimes is possible and sometimes it's actually really hard to. Yeah.
Okay. Well, we can jump back to the slides, and we're now going into a bit of a Q&A side to this session. If there's, like I said, if there's any comments coming live from anyone watching, then please feel free to put them into the comments. We're looking at those now. But some of the other questions that I guess I wanted to know is, obviously you've brought you've done an experiment and you had a particular fault. So first one, we looked at getting rid of a pod. We then looked at getting rid of VM scale sets, and we switched over regions as well. If you've got a fault that you want to test that isn't there already, can you bring like your own fault?
Yeah, that's an interesting one. I did start with the word yes, not at the moment, which should have been the proper answer, but it is a question that's been asked of the Chaos Studio team, and absolutely, technically you can, but I think what they're kind of a bit reserved on whether they want to release that as a feature, mainly because it might well bypass if you, for example, put a bunch of PowerShell or some CLI inside a bring your own fault type experiment. It would be much harder to really ensure that that experiment is running where you intend it to.
Yeah.
So I think that might be coming, but it'll be interesting to see how it is that the assurances that you're running it against the right thing, the right environment, effectively, not necessarily the right thing, but is it, definitely running against the for example, the test infrastructure and not the production infrastructure.
Yeah. Okay. And I guess looking forward then, obviously load testing has since come out in general availability since you last did your original LunchBytes session. And so we're able to showcase that's full potential right now. Chaos Studio isn't quite out generally available, but do you have an idea, I guess, of what the future looks like for Chaos Studio?
I've had some chats and I've seen some internal documentation. What is most important to Chaos Studio is that the fault library, for want of a better word, becomes sort of larger and larger. There are some really quite popular services that don't have fault libraries, and whilst they're still trying to decide on whether bring your own fault is a good idea, what they've done is that they internally within Microsoft released a toolkit to each of the product teams so that they can start incorporating those into their services, especially the control plane ones specifically. And I think it's really up to each of those products to sort of set the schedule for that, as much as I think the Chaos team would like to push it further. So definitely the fault library is increasing. We'll probably see something on bring your own fault at some point as well. But I think there's still plenty that can be really useful here in its current form.
Yeah, no, I've certainly seen a lot of value already just now. But yeah, more faults, anything like that, more types of experiments, that'd be brilliant. And then the other question I wanted to ask is, see, kind of said when Chaos Monkey sort of started and we were doing chaos engineering, originally people used it on production, and the purpose was you should use it on production because that makes most sense. It's the most realistic, right? And you should really find out how your systems are gonna work under stress, under chaos. Should it always be done in production?
Yeah, and that is one that is quite a perplexing one. So what I would say, and particularly when I showed in an earlier slide that you're going through this circle of improvement of where you're doing your experiments, looking at the outcomes and improving things. While you're in that cycle, try to keep that away from production, because these end up being, as you can see with my NOPA one, real disruptions. So what I would say is that you need to get to a certain level of maturity of using these tools before I would want to try this stuff out on production workloads. And I kind of know the idea behind it. And I think to a degree, Netflix, because it's a subscription video service, if something glitches out briefly, there's not really an economic cost in the same way than if you're doing, taking Black Friday orders on an e-commerce system. So I think that starting off, understanding all of your real points of failure and designing those out certainly could give you more confidence to run it in production. I personally wouldn't particularly want to press that button, but I can understand why it's an interesting goal to have.
Yeah, that's a very fair reason. Well, that's all the questions on our end. Just wanted to say thank you so much, John, for running that session for us, for going through those demos and editing them together. It's really valuable. I've certainly learned a lot. So thank you so much. Okay, so there's just one other thing that we wanted to mention as we wrap up today's episode, is we want to talk about, for example, the Cloud Skills Challenge. And I saw that there was a comment live around the Cloud Skills Challenge. Is it just the load testing? No, it's a collection of modules that we've brought together for all the LunchBytes sessions that we've done very recently. So you've got, for example, coming up, you've got some Power Apps modules, and today there's a load testing module as well in that Cloud Skills Challenge. But if you go ahead and start to take part in that Cloud Skills Challenge, you've just got to complete 3 modules. And if you're based in the UK, you can get some swag. I see, Steph, is there something that you're going to mention on that?
No, I was just going to mention that I noticed that we have a few people from around the globe, and that this Cloud Skills Challenge is local to the UK residents that we have here. But definitely check out Cloud Skills Challenges in your region with your specific localized Azure teams. They would love to run Cloud Skills Challenges with you and your team as well. So if you're already working with Microsoft and you want a Cloud Skills Challenge run in your account, please reach out to your account management team, and they'll be happy to help you with that.
Yeah.
Another note real quick is we also have our UK developer website, which is up and running. There's a few new things that we've added. So we have Bit the raccoon, who is now powered by Microsoft Learn in terms of like questions that you have, and they will pop up some Microsoft Learn modules to help inform you. And then we also have some really amazing accessibility features that we've added to our website that you should go check out at aka.ms/UK developer, which is up on the screen. Thanks, team. And really excited to talk about our communities. They are our favorite people over here in the UK. And so if you want to check out the same website, go to the community tab, and you can check out if there's any communities near you that one of us will be there, or one of the Microsoft people, or one of our Microsoft most valuable professionals, our MVPs, is leading. We have a really strong community here in the UK to tap into. And then next week, I'll pass over to Asa to talk about the next session, not next week, but the next session that we have.
Yeah, of course. So in 2 weeks' time, I'll be presenting with Ola on tips and tricks for Power Apps UX best practices. So both how you as a developer can incorporate these within your design to make your life easier when programming, and also to really enhance your user experience and make your app more usable and more kind of friendly for the end user as well. So yeah, stay tuned for that. It'll be a really exciting session. And we'll also be touching a little bit on Figma as well. So using a lot of different platforms.
Great, awesome. Looking forward to it.
Next week at aka.ms/lunchbytes every other week that we run the sessions.
Thanks, everyone. Have a great time, and see you in 2 weeks' time.